Properties of transition elements. Let's begin with the magnetic property. Transition elements and their compounds are generally paramagnetic due to presence of unpaired electrons in their d orbitals. Paramagnetism is a property by which a substance is being feebly attracted by external magnetic field, and it is due to the presence of unpaired electrons in it. And we all know that transition metals are the elements which have partially filled d orbitals. This property or this paramagnetic behavior is measured by a property magnetic moment, which is calculated. The value is calculated using spin only formula, that is mu is equal to under root n plus 2. Here n is equal to number of unpaired electrons that are present in that element or compound. So let's take up an example. Suppose we have to calculate the magnetic moment of Fe2 plus ion. So for this we have to see the number of unpaired electrons in it. First, take the atom. Fe has atomic number 26. So its configuration is argon 3d6 4s2. Configurations are very important. You must learn them. Now here the children do a mistake. They take the value of n as 6, that is the number of d electrons, but actually it is not the number of unpaired electrons. Let's see how these 6 electrons are present in d subshell. We know that there are 5 d orbitals and 6 electrons are arranged like this. So we have only 4 unpaired electrons, so we have n is equal to 4. Now putting this value of n in the spin only formula, we have mu is equal to under root 4 plus 2, that is equal to under root 4 into 6, that is equal to under root 24, and the unit for it is Bm, that is Bohr's magneton. So there is no need to calculate this root value. This much is sufficient to give the answer in root. So you must learn the formula to calculate the magnetic moment. The higher the value of magnetic moment, it shows the number of unpaired electrons are more, and more the substance will be paramagnetic. More the magnetic property is shown in that compound. So this is important to learn the formula. This mu is equal to under root n plus 2, and the unit also, that is Bm. There are marks for unit also. Another property of transition elements is formation of colored ions. The compounds of transition elements are generally colored due to d-d transition of electrons. Now what is this d-d transition? Actually, the d orbitals in an isolated atom are degenerate. Degenerate means they have same energy. But during the formation of compound, these d orbitals, they split up into 2 sets. See, this is the d orbital of an isolated gaseous atom. When certain group of atoms come near it during the formation of compound, they split up into 2 sets, one with lower energy and one with higher energy. 3 orbitals in lower group and 2 orbitals in higher group, with an energy gap of delta E, you can say. So suppose there are 6 electrons present as in the case of iron. We have these 6 electrons in this set like this, because in the lower energy set, because they follow Aufbau principle here also. So lower energy orbital is filled first. So now these electrons, they can gain energy from the visible light and jump from the lower set to the higher d orbital. Okay, so this is what is exactly dd transition. Now because this is a small energy gap and the electron gain energy from visible light only, and the color reflected is the complementary color, the compounds are generally colored. So the term you need to remember is dd transition of electrons. For this is the key term. In the reasoning question you have to write this only, that due to dd transition of electrons their compounds are generally colored. So this is one thing is asked in exam. Another thing that is asked in exam, that out of the following ions which are colored and which are not. Suppose we have scandium 3 plus ion, Fe2 plus ion, Ni2 plus ion, and say Cu plus ion. It is asked which of the following ions are colored and which are not. So you have to check in which of these dd transition will be possible. So the cases in which dd transition is possible are when there is partially filled d orbital. Okay, so when partially filled d orbitals are there, then only electron can jump from a lower set to the higher d orbital set. That is, d orbital should have a configuration of d1 to 9, that is n minus 1 d 1 to 9. This should be the configuration for showing colored ion or the colored compounds. So for scandium the atomic number is 21, that is configuration is argon 3d1 4s2. For 3 plus ion it becomes argon 3d0. For Fe2 plus iron we have 3d6 4s2. So for Fe2 plus we have argon 3d6. Nickel is 28, configuration is 3d8 4s2. For 2 plus we have argon 3d8. Now for copper, the exceptional case you have learned yesterday, that it has a configuration 3d10 4s1. So for copper plus we have argon 3d10. One electron is removed from the s subshell. So out of these we have 0 electron in d orbital here and 10 electron in Cu plus. So these ions do not fall in the category of n minus 1 d 1 to 9. That is, they don't have partially filled d orbital. In first case the d orbital is empty, and in this case the d orbital is completely filled. So these ions are colorless. Okay, this is colorless and Cu plus is colorless. But these two ions will be colored, because in this the dd transition of electrons is possible. So this is something important asked in exam. You must learn these, and for this you need to learn the configurations also. Thank you.